Alrighty, part 2. Let's start with this. It says if a function is differentiable at c, then it's continuous at c. The converse is not true. Just because it's continuous doesn't mean it's differentiable. All right, pay attention. Let's say that again. If a function's differentiable at a c, it's a point on the curve, then it has to be continuous at that point. But just because it's continuous doesn't mean it's differentiable. And here it says if a tangent line at a given point is vertical, the function's not differentiable at that point. Remember, derivatives are slope, okay? If I'm graphing lines, and I have a horizontal line, its slope is 0. 0 is a number on the number line, that's peachy. If I have a vertical line, its slope is undefined. Slope is derivatives, so there's no derivative if it's undefined. Hence, that was our problem up here. We ended up with something that wasn't real, so the slope doesn't exist. Okay, we're going to talk about examples. We're going to keep scrolling here in a second. All right, functions that are continuous and not differentiable. My examples here would be absolute value of x and the cube root of x. Okay, the graph of the of the absolute value looks like this. The graph of the cube root goes like this. Okay, this one has a sharp point. This one has a vertical tangent line that we're going to talk about in a second. Functions that are not continuous and not differentiable at all points. Well, trig's the easiest. The tangent of x. It's got asymptotes in it, right? Step function. This is the donation. That's step function. It's got jumps in it, okay? Any piecewise function with a jump is not going to be continuous. All right, so let's talk about these examples where they have a sharp turn. This is a sharp turn. This is a vertical tangent line. So let's start by a refresher. The limit as h goes, bad handwriting, blah. As h goes to 0 of f of x plus h minus f of x over h. That's the definition. And you have to write the whole thing out. We usually only ask you to do it once because it's a pain in the butt. All right, sharp turn. So absolute value graph, x minus 3, what happens to the graph? That 3 shifted it over to the right 3. If I want to take the derivative, f prime at 3, it does not exist, okay? And the reason being, in order for it to be differentiable, the limit as x approaches c from the right has to equal the limit as x approaches c from the left. Okay. So if you think about it, this is the alternative form. We're going to talk about that in our next lesson. So we're going to ignore that and just use our brains. Okay, if it's coming in from the left, it means I'm coming this way. What's the slope of that line? It's -1. Okay, if I'm coming in from this side, as from the right side, it's +1. Since the left does not equal the right, it's not differentiable at that point, okay? It's continuous, f of 3 is defined, but your derivative coming in from the left and right are not equal. So it's not differentiable, okay? So there's your answer. A vertical tangent line, okay? This is, the graph looks like this, okay? And remember when we did we're worried about that point right there at 0. if I pick this point, there's my line. Pick this point, here's my line. If I pick this point, here's my line. And what happens is that slope of my tangent line is slowly becoming vertical. And remember, the slope of a vertical line is undefined. So this does not exist. Because that tangent line, even if I come from this way, I pick a point here, here's my tangent line, here's my tangent line, here's my tangent line. As I get, if I put this in my calculator and blew up that graph, it would be coming in like this, okay? My tangent line is here, 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 and it ends up being vertical at that point, and it does not exist, okay? So if f of x is differentiable at c, then it's continuous. It has to be. If it's continuous at c, it may or may not. May or may not. Okay. Stay tuned. We'll start part 3 when I pull up the next slide.